Okay, good afternoon. So what were we doing in the last class? We're looking at function modeling. Why is function modeling important? Hmm? To check? To check usefulness, sufficiency, okay. To identify system failure, okay. See, system failure, though, you would anyways know something is working, not working, that is a system failure. Why do we need function modeling?
To describe the usefulness, performance, cost.
That is the process of doing function modeling. Why do we need it?
Functions.
So categorizing is something we do. That is a process of modeling. Why? My question is why? To be able to zero in on the easiest problem that we would want to solve. See, when the problem appears in front of us, at the beginning, it may be overwhelming. We may be completely lost about where to pick the, threads from and how to solve that problem in the first place. And there, an engineering model of the system, the function model of the system, helps us to make the first headway. It brings to us the clarity that we need to estimate, oh, this is where I want to work. Are you able to see this? So now, to be able to bring that clarity, there are these certain rules that we have to follow when we do function modeling. So what are those rules?
Interaction is only touch based.
So a function would exist only in that place where there is a interaction happening. Interaction matrix में अगर कहीं पे plus है, तभी a function can exist. Otherwise, a function doesn't exist. And that plus in the interaction matrix means touch for us. Hmm? Okay. What else? What other rules?
We cannot use any declarative verbs.
We do not use any declarative words. Like we do not use words like protect, clean. Instead, we use words like deflect when we're talking about the bullet, stop if you were talking about the bullet, or remove when you were talking about plaque and food entangled between the teeth.
Carrier and receiver must be identified.
A function has a clear carrier and a clear object of the function. And there is a clear parameter of the object which is either changed or maintained. So we have to identify that. And this carrier and the object have to be at the same level of component hierarchy. Okay, what else? यहाँ पे सब कुछ लिखा हुआ है आपके लिए.
Negative formulation.
We cannot use any negative formulations. The formulations have to be only positive. Okay, what else?
We document only consequential.
We document only functions of consequence. Now, what are functions of consequence? What defines that?
Air cools coffee and not coffee heats air.
See, when I'm worried about getting a hot coffee, then which one of these two is a consequential function?
The air is cooling the coffee.
Air cools coffee is a function of consequence. But if I'm the one designing the air conditioning system, then coffee heats air is also a function of consequence. So a function of consequence is defined by the problem that I'm trying to solve. The same system, but the function model can be very different if you are trying to solve a different problem. So function models are contextual. There is a strong sense of context when we talk about function models there. Are you with me? Okay, what else did we learn?
We have as specific as possible.
We have to be as specific as possible. If we are unable to find a verb, नहीं समझ में आ रहा कि कौन सा verb use करें, we go to the language of carrier changes or maintains y parameter of object. Changes it from P to Q, whatever. So we have to be as specific as possible, because the more clarity we bring to the correct functions or useful nahi bolunga, useful is a keyword there. The functions that we need to model, the functions of consequence, the more clarity we bring to those functions, the easier will it be for us to analyze and identify that place where we want to act. Okay? And then what did we do after that function analysis? So, सबसे पहले तुमने functions identify करे. Then we said, now let us categorize them as useful and harmful functions. Harmful functions you have to remove. The more harmful functions you remove, the better and more efficient your system becomes. There is no other deliberation on the harmful functions. But on the useful functions, you still need to deliberate how to change them, how to correct them, how to modify them. And therefore, for the useful functions, you go into a method called ranking them. We looked at one way to rank the functions. When you did the hairdryer experiment, something with yourself or with your problem statement, we looked at one way to rank the functions. That was, if a function is acting on the target, it is referred to as a basic function. What is a target?
Part of super system, object of main function.
So target is part of super system, one keyword. What else is a target?
Object of main function.
It is the object of the main function. Now, what is this main function? What is this main function?
What does the system exist?
It is the function for which the system exists, for which the system was put in place. So if a robot is being built to remove weeds, then weeds are the target. And the main function is remove them, dislocate them. Are you with me? If the function was to distribute fertilizer, then fertilizer is the target. And the main function is to dispense fertilizer. Are you with me? So we started to rank the functions. We said any function that acts on the target is a basic function. Then we said that any function that acts on other supersystem components, not the target, other supersystem components are additional functions. To the basic function, we gave a value of 3 units. To additional functions, we gave a value of 2 units. And then we said that there are many functions that are there which are happening within the system, within the components of the system. These are auxiliary functions. We gave them a value of 1. Now, this was one way of ranking that we had used. This is not the only way of ranking. For you, you may define that, okay, in my product, I would rank based on what is the MPV. Now, that becomes a little more complex, because main parameter of value, which is taking me closer to main parameter of value, which is not related to the main parameter of value, you would rank something else. So there could be other ways to do the ranking also. But why do you do this ranking? Why do you do this ranking? किसी को 3 बोला, किसी को 2 बोला, किसी को 1 बोला. We looked at the example of the toothbrush. We saw that the bristles had a rank of highest, total में highest bristles का आया था.
The rank will be functional, but it's functional main system.
It is the importance of that part
how much important it is.
It tells me what is the importance of that part. There is a keyword that we use for it. Value. The total functionality divided by the cost. And I will be able to arrive at value. So I will be able to associate value with my components if I rank my functions well. That is why I said that I have just given you one way of ranking functions. Depending on what system you are working on, depending on what problem you are solving, you may want to have a different methodology. You may start with this, but you may want to evolve a different one for yourself. Are you with me? Because value of a function is what we are looking at. And therefore, a very logical connect would come to main parameter of value. If something is connected to main parameter of value, you would value it more. If no, then no. Are you with me? Then, what else did we say? We said that we also have to label the functions on the basis of their performance level. Normal, excessive, deficient, or insufficient. And it is not that excessive is good. In the paint example, we saw that when the pump operated excessively, that led to the paint overflow. So, जितना insufficient बुरा है, उतना ही बुरा excessive भी है. In an ideal system, things work as they were designed. Neither more nor less. Both lead to wastage. Both lead to some problem sometimes. Are you with me? Is the last class refreshed enough now? Any questions from the previous session? How many of you actually went back and tried to model your system by using these rules? Okay. बाकियों ने नहीं करा? So you will struggle then. I'm telling you. You have to practice. This doesn't come easy. See, you're learning a new language altogether. Has anyone ever told you to be so precise, so careful about how to do something when using words or language? Has anyone ever told you earlier? This is the first time you are learning this kind of a language of inventive problem solving. If you do not pay attention to it, if you do not put effort onto it, you will not be able to learn this language. Have you tried learning any other language? Let us say French, Japanese, English to aati hai sabko. Any other language? Anyone has tried? So are you able to use that language if you do not practice on it? Has it ever happened with you? You might know Punjabi, but if you don't speak in Punjabi and you do not practice Punjabi, you will not be able to then use it. Any language. So over here, we're talking about a new language. And it's not the first time I'm informing you this. We've been talking about a new language from the first session. So if you do not practice, it will be difficult. And it was not that I did not nudge you. I had told you at the end of my previous session that do practice. Please do. It's important. You've lost 5 days. And it's not a small time, by the way. It was an opportunity for you to practice and get more acquainted with the system that you are going to work on in your problem statement. Please do. Any questions? Those who practice, did you struggle? Did you have some challenges when you were designing those models? I would be surprised if you didn't have, because I had. I had to make quite a few assumptions. And okay, for me, when I learned TRIZ, there was no one to really help me at that point of time.
So our project was RO filtration system, and we had to minimize the water wastage. So here the purpose is clear that we use the RO purification system and with as minimal water wastage as we can. But then, what will be the target here? Is it the water we are targeting, or like?
No. So water getting wasted is a harmful function. This you have to eliminate. Your ideal, so there is this concept of ideal final result in TRIZ. We'll talk about it later. But there is this concept of ideal final result. What is the ideal final result for water purification? That water is purified and no water is wasted, is it not? So water being wasted is a harmful function. You have to remove it from the system actually. Are you getting it? Your target is remove dissolved salts from water. Remove dissolved salts, keh lo, impurities, keh lo, whichever way you want to look at it. Your target is remove or kill bacteria from the water. So there are two targets, bacteria and salts or impurities. Impurities को आप इसको 5 बनाना चाहते हो तो 5 बना दो, that doesn't change.
सर एक इंटेग्रल मैट्रिक्स से मतलब 3-4 टारगेट कर सकते हैं.
As I said, now the main function is remove all these 4 things from my water. So yes, there are 4 targets. You may want to club them into one for your ease of purpose, but if the removal technology or process is going to be different for each one of them, then you are talking about a combinational system, a complex system, and therefore there are multiple targets. Are you getting it? So you already know that in an RO system, there are multiple ways you remove different kinds of impurities. So you will have to model each of those ways. Each of those are components in your system. Now, by modeling all of them together, you may also see where can synergies exist. देखो वहां पे sedimentation filter था. Can I use it for this purpose also? Then you will be able to utilize synergies across systems which are otherwise completely independent. And that can give a strong boost to the efficiency of your system. Are you getting it? So see, this kind of things happen. Because मैंने तो आपको एक बहुत simple था. I gave you a very simple example. When you will go on to implement it on your problem statement, such kind of questions will come. Now, water wastage. Water waste अब target क्या है? Water है कि वो है? Water wastage is something I want to remove. It's a harmful function. That is what you will be able to check with me, clarify with me if you practice. Otherwise, you will model water as a target. Is water the target? No, water is not the target in an RO. Are you getting it? So please practice. It's important. Any other questions? Any other confusions you struggled with? Yes.
So we have the solar efficiency struggle. So in that solar panel get dusted. So we use water as a cleaning agent to remove the dust so that the efficiency is at minimal. So the water gets wasted a lot over there. So but now we have taken water as a target. So we have to either reduce it or find other some solutions so that.
Okay. So it is slightly tricky for you again. That the main function of your system. What is the main function of your system?
Find an alternative way of clean those panels.
So main function is to remove dust or particles from the top of solar panels. Water cannot be the target. Water is still a super system resource that is getting wasted. And you have to somehow zero the wastage. It's a harmful function that is happening on a super system component.
So our target would be to clean the dust. And
or you may say that water is also a part of my system because I'm using that fountain of water as a means. So then water becomes your resource, and then your problem becomes a problem of reducing the cost of my system by reducing water consumption. You again do not say water wasted, you say reduce water consumption. Are you able to see this? Anyone else? You see, by discussing these, each one of you will actually get much more clarity about how to do function modeling for your system. Please practice. It's important. For you. मेरे को आता है. ठीक है? So now we come to the next step. See, what we have done until now is we have modeled our engineering system, and we now want to see how to solve the problem. So we'll use the first or the next tool of problem identification. So देखो क्या होगा? For many of you, when you are doing the function modeling itself, the problem is evident. Okay? The problem is evident, but it might be very difficult to solve. So now we will play with this model and use this tool called trimming. Okay? Now we'll use this tool called trimming, and we will try to restructure the function model and therefore redesign my engineering system. You do realize that the model and my engineering system are actually coupled. If I change my engineering system, the model would get updated. If I change my model, I am in effect trying to change the engineering system and solving the problem. So now, because we have a model, we'll now play with the model. It is easier to play with models, is it not? All of you must have done some simulations at some point of time. So you play only with models there, because you cannot get everything real in front of you. The concept of digital twins, whatever you talk about, is all about modeling so that you can do it cheaply, quickly, and effectively. So now, since we have a model with us, we will play with it to identify cheaper problems, simpler problems, and redesign my system. Is that okay? So we'll enter into what is called as trimming. So trimming, and I'm reading this out over here, trimming is an analytical tool for removing certain components and redistributing their useful functions amongst the remaining system or supersystem components. I repeat, trimming is an analytical tool for removing certain components and redistributing their useful functions. I'm stressing on the word useful over here. Useful functions amongst remaining system or supersystem components. What do you understand by this statement? Because I know what trimming is, I know this is a very precise definition of trimming. You do not know that yet. What do you understand by this statement? There are not main functions we are trying to solve them to the target. I've not really talked about functions anywhere except this phrase of useful functions. So you're talking about removing components. We can remove add the functions of the components into the required components. We can add functions. So we are removing some components, but those components may be performing some useful functions. If a component is performing some useful function, something else needs to perform those functions. And we want to redistribute them. So this is an analytical tool to be able to do that. It's a kind of a flowchart, a method, an algorithm. Is that okay? So you remember when I was introducing Chris to you in the first session, I talked about this motorcycle. And I said, my target is to reduce its cost. And then I had shown you this function model. At that time, you may not have understood it well. But now just spend 2 minutes to review and see that this function model is working or not. What are the components of the system we are talking about? Motor, wheels, frame, gas tank. What are the super system components? Road, driver, gas. Who is the target? Driver. Why does this motorcycle exist? To move the driver. Hmm? Then uh, you notice the functions. Motor rotates wheels. Wheels move frame. Frame holds wheels. Frame holds gas tank. Gas tank contains gas. Now, which is the basic function? Which is the basic function over here? Frame is a component. I'm asking which is the basic function? A function has carrier, verb, and object. All three things. What is the basic function? Frame holds driver. That is the basic function. And that is the only basic function in this model that has been presented to you. Are you able to see this? What are additional functions?
Gas tank contains gas.
Gas tank contains gas.
Just that.
Just that. Driver controls motor is an auxiliary function. It is happening on the
Frame.
system component. Who is doing that function doesn't matter. The object of the function is used to define whether it is an additional function, auxiliary function, or the basic function. Are you able to see this? Now, which are the auxiliary functions?
Motor rotates.
Motor rotates wheels, wheels moves frame, frame holds wheels. Driver controls frame. That is also an auxiliary function. Road holds wheels. That is also an auxiliary function.
Frame holds.
Gas tank contains gas as an additional function. Gas is a super system component. Frame holds motor is also an auxiliary function. Driver controls motor is also an auxiliary function. Are you able to see this? Now you are asked to reduce the cost. And we start to remove some components. That is what trimming is about, removing some components. So what can you remove? Can you remove the driver? No. Can you remove the gas? No. Can you remove the road? They are super system components. You can't touch them. From amongst the system components, motor, wheels, frame, gas tank, what can you remove?
Gas tank.
See, can you remove the motor? As soon as you remove the motor, the main functionality of motorcycle is gone. It only remains a cycle then. No? Then you remove the wheels. Again, the main functionality of moving one object, that is the driver, from one place to another, that gets severely hampered. You remove the frame. Oh, then who will hold the driver? Driver can't be sitting on the wheels. Who will hold the wheels? All that goes for a toss. Gas tank, you can think of removing. But then, if you think of removing the gas tank, what will hold the gas? So now we say that some other component in my system has to hold the gas. And frame is already holding so many things. It is holding the driver, it is holding the wheels, it is holding the motor. Let it hold one more thing. Let it hold the gas also. No, 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 there's something to laugh about. This is the algorithm. We look for other components in the system that are performing the same function. They are Okay, frame is performing the same function, then let us try to give this function also to the frame. And as soon as you do that, you have a cheaper version of the motorcycle. Are you able to see this? So आगे से अब कौन कौन cheap motorcycle चलाएगा ये वाली? वो कह रहा नहीं, मैं तो नहीं चलाऊंगा. Because one function of the motorcycle we agreed was not mentioned here. What was that function? The frame or the motorcycle informs the onlooker, which was a super system component. What does it inform? Oh, I am a Tashni guy. Now this Luna doesn't communicate that. Therefore, MPV got violated. So when we do trimming, it is important to keep MPV in mind. That is why I said, while I'm giving you a very simple method of ranking or ascertaining value of components, you will need to use MPV also sometime so that you don't end up into this kind of a situation, into this kind of a solution. Are you able to see this?
सर ड्रिलिंग तो लॉन्ग टर्म के लिए ठीक नहीं है.
क्यों नहीं है ठीक?
सर अगर हम जो नॉर्मल गाड़ी होता है उसमें कुछ दिक्कत हुआ टैंक में लीकेज हुआ तो चेंज कर सकते हैं. अगर ड्रिलिंग में चेंज करना हुआ सिस्टम चेंज करना पड़ेगा.
तो फ्रेम को अच्छा बनाओ ताकि दिक्कत ना हो. पहले आपको 10 चीजें अच्छी बनानी थी, अब 2 ही चीजें अच्छी बनानी है. Wait. As you reduce the cost of production, there is lesser thing to handle, lesser challenge to handle. You can actually focus on more better quality. See, so that is where what we did not look at was the exact cost. हमने इधर अभी trimming के mechanism में cost को नहीं लेकर आए थे. That is where the solution came like this. Finally, see, when you will work on your systems and you will want to optimize them, it is really, really important to apply trimming onto your systems to optimize them. In fact, trimming is a very, very powerful tool when you're writing patents also. See, when you write a paper, you want to give too many details so that others understand your idea well. They can replicate your idea. They can validate your idea. Patents, on the other hand, are very different. We'll talk about patents in a different class. But patents, on the other hand, are very different. Patents are about informing that I have this solution and don't even try to use it. If you use it, I will charge you royalty. So you do not want it to be easy to use for them. So you have to remove the fluff. But if you remove everything, then what will you patent? So trimming is a very powerful tool to remove the fluff while still maintaining the minimum essence that protects your idea. Okay? People use trimming to also circumvent other people's patents because they might not have used trimming. So you circumvent their patent by saying, oh, तुमने अपने patent में लिखा था ये 5 components की जरूरत है. By using trimming, I can get the same function through only 4. So I'm not violating your patent. So you circumvented a patent just by making the function model and doing trimming. Saved millions of dollars of research. You check out the kind of patents Hyundai files. Hyundai में एक department है that picks up every patent that Toyota has filed. And it applies trimming on it. And it reaches market faster than Toyota. Because now you have to do fewer components. So trimming is a very, very powerful tool. Aditya, it is a very, very powerful tool.
So how we make sure that it is containing all the components like we went from product frame to hashtag. Is it like frames आगे पीछे is like body वाला part that वाला bone?
So again, I'm not going into how to do the component analysis. That we've already discussed. You do the component analysis of your system well. This was just to tell you that trimming can also go wrong. But I'm also telling you in the same breath that trimming is a very, very, very powerful tool that people use very widely to strengthen their product portfolio. Okay? You might be thinking of a very interesting solution to a problem, but then there's a patent that is blocking you from using that solution. Apply trimming, and you will have an answer. Majority of the times, you will have an answer. Okay? So, let's go to how to do trimming. First, select components based on project's goals and constraints. Okay? आपका पूरा फंक्शन मॉडल has to be built based on project goals and constraints. कि आपके प्रोजेक्ट का गोल है कि आपको कॉस्ट रिड्यूस करना है, आपके प्रोजेक्ट का गोल है कि आपको वाटर वेस्टेज रिड्यूस करना है. सो यू हैव टू minimize consumption of water or whatever. There is a project goal and there is a constraint that you still have to do it within 2 minutes. I could purify water in 1 hour, but the constraint is you have to do it in 2 minutes. Now you need to do something. You need to have an active filter. You need to have some active membrane. Otherwise, sedimentation कर देते हो जाता. So then identify the key disadvantages. You've already done that. See, that was done even before we entered into function modeling. We analyzed our system, identified the key disadvantages. So we pick the components that have the key disadvantages associated with them, and we remove them. You will find that most of these key disadvantages are linked to harmful functions. So another way to quickly identify what to trim first is components which are causing harmful functions, carriers of harmful functions. Okay? So carriers of harmful functions are usually the functions that lead to key disadvantages. Definitely they are leading to some disadvantages, but key disadvantages भी उन्हीं में से कहीं से होगा. तो identify करो which one is the key disadvantage causing function. Trim that. Trim that matlab you remove that. Now, there are 3 rules for trimming. We will use them to do that removing process. Okay. Now, we do not trim. We do not trim that particular component if there is no feasible alternative to which all the useful functions or no feasible alternative matlab एक component nahi, across components you have to distribute all the useful functions. If you're not able to do that, you cannot trim this particular component. Okay? So what do? In such a case, you go and perform radical trimming. तो trimming का बाप. Trimming ही है, लेकिन इतनी तगड़ी trimming है कि आंखें बौखला जाएंगी, चौंधिया जाएंगी. ठीक है? Trimming तो हम करेंगे ही, तुम देखो अब. That kind of a thing. So trimming you do if you get a good alternative. If you don't get a good alternative, go for radical trimming. Look at both today. Okay? And then trimming can be less or more conservative depending on the number and relative importance of trimming components. So number of components is easy to understand. Relative importance comes from the value part of it. That is, the components that you have removed are of low value. They had almost no function visible to the super system. They were only doing auxiliary functions. Then you say it is mild trimming. When you do something big, where the basic functions or additional functions are also changed, that is where you start to do radical trimming, or that is where the trimming is big in itself. Is that okay? Any questions here? Okay. So, the main idea is that less is more. Rules of trimming. First rule. Again, now these are key rules. जैसा हमने functions के लिए कहा कि additional, basic, auxiliary functions. These are keywords, key terms that you have to take care of. So again, for these rules, these are the rules and have to be applied in this sequence only, A, B, C. Rule a function can be trimmed if we remove the object of its useful function. If the object of the useful function doesn't exist, then you do not need the carrier also. You've kind of done away with the function altogether. Is this clear? If the objective nahi hai, if there is no object of the function, then there is no action that this component is performing. Why have it there? Remove it. See, आपके यहाँ पे कभी दर्द होता है, आप डॉक्टर के पास जाते हो, ऐसे ओ आपका अपेंडिक्स इशू है, अपेंडिसाइटिस हो रहा है आपको. Let me remove it. Remove it, ना? No other consequence. 2C laparoscopic surgery होती है, अपेंडिक्स को हटा देते हैं. Because it has no useful function in my system. Are you seeing this? So that is rule A for trimming. Yes.
If there is a function carrier which has more than one functions and acting on more than one object, so each and every object has to be removed to remove the functional carrier.
So if you've already removed it, then it has already happened. If you have not, then yes, you have to remove. Or then you have to remove. That is the rule A. Okay. Now, if you're not able to remove the object of the function, then what do? Let the object do its function by itself. Self-service. Somehow, now ये समझ में नहीं आ रहा ना अभी. How can it happen? Something else was doing it. Now let the object do it. For example, I was using a frame to hold this table there, the surface of the table there. Okay. I want to remove the frame. So something has to hold the table here. What if I design the tabletop in such a manner that there's no separate frame. The tabletop itself holds itself at the height. Can it happen? Now, there is no separate component called frame. There is only a tabletop which is shaped like that. Are you able to see this? So now I don't need any iron. I just need to go to the carpentry shop. Are you getting it? So I've reduced the component I've trimmed because the object of my function was able to take care of the useful function by itself. Is this clear? We'll see all these in action. Don't worry. You will see all these in action, and when you will practice it on your system, you will see much more things coming in. That is why practice is important. Huh? Third function, or third rule. If the object cannot self-serve, then assign that function to another component in the system or the super system so that that useful function is still performed. So the statement is, function carrier can be trimmed if another component performs its useful function. That component can be a system component or a super system component, but the useful function is taken care of. This is simple to understand. All right? These are the three rules that you have to apply to trim any component. First, trim components if there is no object of the useful functions. Trim if the object of the useful function can handle the function by itself. Trim if something else can handle that function for you. Okay? We'll come to that. His question is, how do I identify of these two carriers which one to trim? So see, we just did the thing of value of every component. So low value components, need to be trimmed out. And when you assign their function to another high value, already high value component, its value goes up.
Trimming is proportional with the cost.
Trimming is proportional to costing. Value is inversely proportional to cost. If something is cheaper, it has high value. So I'm saying low value components ko trim karna matlab costly components ko trim karna. Costly components which are not performing very important functions. Trim them out first. Are you able to see why that ranking was important? Why that value estimation was important now? Because what you will trim will come from that evaluation that you had done. Are you able to see this? Any questions? Okay, so summarizing all the three rules once again over here. Function carrier can be trimmed if we remove the object of its useful function. Function carrier can be trimmed if the object can perform the function by itself. Function carrier can be trimmed if another component can take care of the useful function. Okay? Now, we come to how to select a component as a function carrier. So first, जो आपको replacement, जो हमने rule C के लिए, how to select an alternate component that will replace your function carrier. First rule, or first thing that you have to check, a component already performs an identical or similar function on the object of the function. Already there is another object that is holding the tabletop. Okay, you also have the frame, but there is this another object that is holding the tabletop. I could have nailed the tabletop onto the wall. So now just strengthen that. It might be performing that function already. You put a frame just to be safe. Now strengthen that. Improve the quality of the hinge that you had applied. And you got it. Then the component already performs an identical or similar function on another object. हमने अभी जो motorcycle की बात करी थी. What did I say? See, it is already holding the motor, it is already holding the wheels, it is already holding something else, and it also holds the gas. I was applying this rule. It is performing the same function on other objects. So it's easy to give it one more function. Its value increased. Are you able to see this? Then, component performs any function on the object of the function, or at a minimum, simply interacts with the object of the function. So the tabletop, the component is not holding the tabletop. It is, for example, beautifying it. It is, for example, making it configurable, whatever, but at least it is doing something to the tabletop. Even if it is not doing something, it is at least touching the tabletop. There is already an interaction that exists. There may be no function assigned with the same interaction, but an interaction exists. Are you with me? That is the third choice. That is the third choice. Then, अगर ऐसा भी कुछ नहीं मिलता, the component possesses the set of resources necessary to perform the required function. So there is a component in the system which may not be interacting with your object, but this component does have the resources to hold the object. For example, over here, to perform that useful function. Those resources exist. It has the capacity, it has the capability. Then you assign the function to that component as a carrier. Is this clear? Is this okay? The four ways of selecting the alternate component which would perform the useful functions. And this you have to do for every function for the carrier that you are trimming. Every useful function. Harmful functions, we already said harmful functions have to be removed anyways. Why? You don't want to assign any harmful function. Only useful functions you will reassign. Are you with me? Any questions?
Can you give an example of it possible the set of systems like where already you're already deciding an individual component and then what kind of set of resources?
So in this table, for example, there are these nuts that are connected. These nuts have the capacity to help me hold the tabletop with the wall. I will assign the function of holding the table to the nuts.
But if the nut is already a component, then we cannot do it.
Nut is already a component, वही तो बता रहा हूं. I want to remove the frame. But there are nuts also that are there in my engineering system. Now the nuts I will use or the nails I will use to nail and put my table on the wall itself.
But it can be, it can come under the second one also, that it is performing the identical function on the other object.
The nut could be there somewhere else, not really performing the holding function. Nut could be there only for decoration also. But the essence is that there is some other function there is some other component which may not be touching your tabletop at all. Not performing the function, but has the capacity, has the capability. You've seen it in other systems that it does something like that. That component again you can reassign. Is that okay? Why is this? So you want to trim because you want to change the problem into a simpler problem. See, आपको कुछ harmful functions हटाने थे system से. Key disadvantages are harmful functions. You have to remove them. Now, your typical engineering solutions that you are looking at, those solutions will take you to reducing the intensity of the harmful function so that it becomes acceptable. That is what we call as optimization. But TRIZ does not believe in that. TRIZ says, I want to find an inventive solution to the problem. I want to completely, because ideally, in my ideal result, this harmful function doesn't exist. So I want to remove the harmful functions. And what we are saying is that trimming the object or the carrier of the harmful function is the best way to remove the harmful function. Are you getting it? Because once I remove the carrier of the harmful function, then who will cause that harmful function? There's none. This is to remove the key disadvantages of your system. Because if you remove the key disadvantage, the problem is solved. Are you able to see this? See, function model in itself may show you that, okay, there is no harmful function or there is just insufficient function happening and you don't need to do trimming. So function model will itself give you that clarity and you may not need to do trimming. But if there are harmful functions, you definitely will want to do trimming. Yes. All the components, because we are starting with function model where we already said that all the functions are defined only between components at the same level of hierarchy. वो तो established already है. That don't change. Is that okay? So now, what we achieve now is called as a trimming model. What is a trimming model? It is a function model of the engineering system as it would exist in the future after trimming. Now it is your job to convert that into reality. हमने कहा ना, I will play on the model and then we will modify the system actually. So this is a model of a future system after trimming where it contains a set of trimming problems, key disadvantages to solve for implementing the trimming model. A different trimming model for each alternative way of trimming is to be prepared. Is it okay? Now, the algorithm of creating a trimming model. Select the engineering system component to be trimmed using the selection guidelines that we just saw. Then select the first useful function of the component to be trimmed. Select the applicable trimming rule. Now, obviously, rule A cannot be applied on basic functions. Rule A means the object has to be removed. Now, basic function is about the target. Target you can't remove. Target is the reason for which the entire system existed. So if one of the functions of the component that you have chosen is a basic function, then rule A can't be applied for that particular function. But you apply rule B and C in that sequence. Okay. Then, if rule C is selected, select the new function carrier and formulate the trimming problem. What is the trimming problem? How do I transfer function from component A to component B? So you change the problem. पहला आपका problem क्या था? पहला problem था how do I solve the key disadvantage? Now the problem is how do I have component B do the job of component A? This could be far simpler than solving the first key disadvantage that we had. Are you able to see this? So what we are trying to do by trimming exercises, come up with new problems of which a few will be cheaper to solve, easier to solve. And therefore, in a very cheap manner, you are able to find a solution, an inventive solution to the problem over there. Are you with me? Then you repeat steps 2 to 5 for all the functions of the component. And then you go steps 1 to 6 for all the components that need to be trimmed. It's a simple for loop, is it not? You've already seen such formulations. आप सब programming जानते हो. It's a simple for loop. For I is equal to 1 to n, check every function for each I, see what is the rule to be applied, come back. It's a nested loop. Are you able to see this? It's not been written like that because that is how Altshuler wrote it, but all of you know the lexicon behind that. Is this flow algorithm program clear? Now, shall we apply it on an example? Favorite example? Paint filling system. So we apply this on the paint filling system now. Now you have this paint filling system and we already made its function model. What was the function model? We saw that there are two reds over here, two harmful functions, float holds paint and air solidifies paint. So what would be the first thing that you would want to trim? Air is a super system component. Can you trim it? You can only trim something from within your system, na? So what is the thing that you would trim? Float. Because float is the carrier of the harmful function, the key disadvantage. There's only one harmful function that the system components have. And that is also the key disadvantage. If that was solved, would the problem have appeared in the first place? No. So you say, I will trim the float. Now, if you trim the float, someone has to move the lever. And see, paint was moving the float. Now the float doesn't exist, that function goes away. Lever was holding the float. Float doesn't exist, that also goes away. The only function I now need to do is somehow move the lever. Are you with me? So this doesn't exist, this doesn't exist, and this doesn't exist. And air भी अब किस पे solidify करेगा paint को? That also goes away. So both the harmful functions are taken care of. But my trimming problem remains as to something has to move the lever. Now you see, there is this rule, which rule A, which said that I can trim the float if there was no lever. I can trim the float if there was no lever. Should we try this? So I remove the lever also. Now I need something to control the switch. The other two functions are taken care of. I now need to control the switch. So lever can be trimmed if, you may say the switch doesn't exist, but let us apply rule C here, where something else can control the switch. Can there be something else that can control the switch? ये कह रहा है यूजर को ही ले आओ, तो ऑटोमेटिक कहां बचा? तो पहले भी ले आते. So now let's look at the function model again. Something has to control the switch. Something has to control the switch. How do you identify that alternate carrier? He said, look around and see if there is another component that is in touch with my object, and doing the same function to some authority. I find there is one component that is in touch with the object, which is a tank. Another component is a motor. Tank is doing some function on the switch, but that function is nothing like control. Okay. Motor is not doing anything on the switch, but is getting controlled by the switch. So something that is getting controlled may not be able to do the reverse operation, may or may not be, I don't know. Then is there anything else where control comes? No. So control function और कहीं नहीं आ रहा. We go to the next row where we say that, is there any other component which is performing any function on the switch? Is there a component? Tank. Tank is performing a function on the switch. What is that function? Hold. Now our problem statement is, can the tank somehow also hold the switch, control the switch? It is already holding the switch. Can it also control it? That is your trimming problem now. Find a solution. The trimming problem is how to make the tank to control the switch. What can you think of? Sensor को हमने पहले ही कहा था अलाउड ही नहीं है. टैंक माइट बी कंडक्टिव, तो वो तो फिर हमेशा ही एक ही चीज करेगा. पेंट माइट बी कंडक्टिव, तो He's saying weight. Okay. क्या करोगे weight से?
Weight keeps the button pressed as soon as it becomes heavy. As soon as it becomes light, this button is not pressed anymore.
Okay.
I think we can have a push button kind of beneath the tank.
A push button beneath the tank, okay, which is pressed when there is sufficient paint, so it switches the motor off, and as the paint amount reduces, the tank goes up So you're also talking about some spring somewhere then? Huh? Sensors are not allowed. That we discussed. वो first constraint था. He had said, I do not want any costly sensors. I do not want nothing like that. See, what we are agreeing to say is that tank will control the switch. How will the tank control the switch is the problem. What have we done? We have trimmed the float, we have trimmed the lever, and we somehow want to control the switch now. How will the tank control the switch? There are ideas, yes.
That's what.
Switch can be placed somewhere under the tank, and the tank is resting on springs. So as the weight of the tank increases, the switch is pressed and you turn the motor off. As the weight of the tank,
For the tank, we can just have this weight thing as well, like something ऐसा कुछ mechanism लगा जिससे switch weight की ratio से switch off हो जाए.
ये spring भी तो वही है. Spring का compression is dependent on the weight, the force that is applied on it. What else is a spring? Tell me, what other mechanism would you want to use? अच्छी बात कर रहे हो. I will give you one more solution अभी. क्यों? This is a mechanical thing. Spring लगा दिया, काम छोड़ दिया, खत्म बात. सेंसर तो लगाओगे तो उसके बाद सेंसर को ट्यून भी करना पड़ेगा. कभी सेंसर के ऊपर मिट्टी जम जाएगी, बेचारे पूरा सोलर पैनल को बना ही इसलिए रहे हैं. मैकेनिज्म बिठाना पड़ेगा, सस्ता थोड़ा ना होगा. तो मैकेनिज्म बताओ कुछ और. सेंसर उसने अलाउ नहीं कहा है. वो कह रहा है कंडक्टिंग पेंट यूज कर लो. दैट इज अ सुपर सिस्टम कंपोनेंट. वी कांट चेंज द क्वालिटी ऑफ द पेंट. Paint is not conducting. Is it paint conducting? Paint is considered to be a insulator. आप पेंट कर देते हो तो जहां पे पेंट नहीं लगा होता वहां पे आपको शॉक लगता है. What else can you do?
So it's like we can put a plate on the top. If plates का level ऊपर होगा तो उससे circuit complete हो सकता है.
They're saying have a floating paint and have a floating paint on top of it, plate on top of it, and that completes the circuit. Okay, how is it different from a float then? Float भी तो वही कर रहा था. वो पहले फ्लोट पे चिपक रहा था, अब तुम्हारे प्लेट पे चिपक जाएगा. बात तो वही रही. तो तुम कह रहे हो कि वो मैकेनिज्म कॉम्प्लेक्स होगा. लड़ो ना थोड़ा सा यार, एक दूसरे के बाल खींचने या हाथ पैर तोड़ने, कुछ तो मजा आएगा. आज आप कोई भी नहीं लड़ा, ना मेरे से ना आपस में. लड़ो ना. ये तैयार है लड़ने को. चलो भाई, ये आ रहा है मैदान में. कौन आ रहा है इससे लड़ने के लिए? ये तो कहेगा मैं नहीं, तेरे को तो मैंने माफ करा, मैं तेरी टीम से उस दिन बच गया था. So, what else could you do? Is there something else which is also in touch with the switch? क्या बोला? Air. How can you use air to control the switch? Now are you realizing? जो ही मैंने air का शब्द बोला, यहाँ से एक solution emerge कर गया. If I could use a piston or use pressure of air in some way, I could be able to control the switch. Now, do you see the importance of putting super system components in my component model? Because now you can go to all the components that are touching your system, touching your object, and see what component can be given the job. Are you able to see this? Now, if you were to use air to control the switch, what would you do?
it's sufficient amount that creates a pressure message in the pipe, and that would not be sufficient pressure to
Something like this, much simpler than the complex imagery you were creating. What is happening here?
reach.
You have some noble gas put in there, choti si amount mein, and as the paint increases, the pressure increases, that pressure switches off the lever, switches off the motor. Huh? So again, you can come up with very interesting solutions. Do you want to try other solutions by yourself? I'll give you an opportunity. So what has happened until now? We are saying that component A functions, basic trimming rules, C, new carrier, component 2, how trimming problem is how to make component 2 perform function 1. So this way you list down all the components which you want to trim and list down what you are doing to their useful functions. Are you able to see this? So the same function 1, function 2, 1, you pick up functions one by one and you can have a complete table with the list of all the trimming problems that you have to solve to arrive at your ideal trimming model or trimming a system which has no problems that were there in the system earlier. इसी को थोड़ा सा और खींचे. अभी तक मजा आया? अभी तक मजा आया? You were able to see the potency of trimming to solve the problem. The number of components reduced, overall cost of the system reduced, and simultaneously what happened? The problems are also getting solved. Now we look at what is called as radical trimming. So what do we do in radical trimming? What we have done until now is we have said that the switch has to, because हमने lever को trim करा, now switch needs to be controlled by something. Now in radical trimming, you say that switch पे भी rule A लगा दो. switch पे भी rule A लगा दिया तो क्या होगा? ना स्विच बचेगा. प्रॉब्लम क्या आई? मोटर को कौन कंट्रोल करेगा? है ना? फिर से रूल है भयंकर, मोटर भी हटा दो. मोटर पे अब पंप कौन चलाएगा? रोहित कह रहा है पंप भी हटा दो. चलो मान लेते हैं रोहित की बात. पंप भी हटा दिया. अब पेंट मूव तो करना है. पेंट मूव करना है और अर्पित कह रहा है अब एयर ही बचा है. अर्पित ने कहा, आदित्य ने कहा लड़ लो यार थोड़ा सा ना, मजा आएगा. तो now what we want to do is somehow air has to move the pump or the paint has to move itself. Something has to happen. So pump can be trimmed if its useful function to move paint is performed by paint. Now rule A is not possible because paint is the target. The entire system existed to move the paint. So now you can't apply rule A, you're applying rule B now. Can the paint move itself? And this is your final trimming model. And the trimming problem is how to make the paint move itself. So batao, how will you make the paint move itself? And when I will tell you the solution, you will see, arre, itna simple tha.
और कुछ ऐसा कर सकते हैं जैसे वो टैंक पे फ्लो कर रहा है तो एक फ्लो चार्ट बना सकते हैं वो फ्लो के वापस टैंक में चला जाएगा बैरल से फ्लो के वो टैंक में
बैरल में जाने के लिए उसको फिर ऊपर जाना पड़ेगा ना। आप ग्रेविटी से नीचे लेकर आए थे, ग्रेविटी को यूज करके। वैक्यूम थ्रू विच व्हाट विल हैपन? वैक्यूम कहाँ होगा? हाँ, इनसाइड द पंप। पंप तो आपने ट्रिम कर दिया। प्रॉब्लम इज हाउ विल द पेंट मूव इटसेल्फ? You're applying rule B. That paint does the job by itself. How will the paint move itself?
support the barrel light and put the pipe at the top of the tank. So you can make the barrel with a slant.
Make the barrel with a slant. You're saying put the barrel at the height and is that how it works? आप टैंक सी, तुम ये कह रहे हो कि एक एक टैंक है, एक बैरल है जिसके अंदर पेंट है, और उसके नीचे से कहीं से आपने पेंट को एग्जिट करने का पाइप निकाला और उसको अपने टैंक के ऊपर डाल दिया. It's on the top of the tank. As soon as the tank gets filled, the barrel will now not empty itself. The gravity will push the remaining paint also out, na? Gravity will push the remaining paint also out.
Instead of putting on the top the inlet, we can put it on the bottom of the tank, and we can add another pipe from the top to that inlet pipe. Put the noble gas over there. Just when it reaches the top level, by the pressure, you can check this pipe inlet. It's like that. जो inlet वाला pipe है, tank के bottom पे लगाया.
The inlet pipe, so paint is coming from the bottom of the tank.
So
paint is entering the tank from its bottom. That is what you're telling me. Okay.
So उसमें एक और टैक्स पाइप से लेके उसी इनलेट पे उसमें एक लीवर है. It's like that. वहाँ पे connected है.
We're adding more things now. We wanted the paint to move itself. ग्रेविटी से तो नीचे ही आएगा ना, ऊपर कैसे जाएगा? उसके लिए तो पंप चाहिए था. पंप तुमने अभी ट्रिम कर दिया. You had some idea.
As soon as the tank fills, आप इसे टिल्ट करते हैं, ऊपर डायरेक्शन fills the tank in charge of the same. So paint keeps refilling. As soon as it fills up, it spills. Goes back. Spills.
Okay, so you're saying that the way the barrel will put paint into the tank is through some mechanism where there is some intermediary जहाँ पे आप कुछ पेंट डालोगे और वो टिप्स ओवर होके पेंट कहाँ जाएगा? Okay, so you're just controlling the flow of paint. Now, if the paint is not utilized, the number of radiators coming is lesser. Then what? It will still start to overflow after some time.
साइड पे ऊंची हाइट पर रख दिया जाए तो पेंट आता रहेगा और जब हेडफोन पे प्रेशर इक्वल हो जाएगा तो उसमें एक पाइप अगर वहां पर लगा दिया है तो काफी सीमेंट इसमें जाता है और ग्रेविटी के कारण जब तक पेंट आएगा जब तक एटमॉस्फेयर प्रेशर इक्वल नहीं होगा.
से आप लोग घूम रहे हो आसपास.
ये इनलेट पाइप है या टैंक पे यहाँ से ज्वाइन किया हुआ है. यहाँ पे अगर एक टैंक को रेड कर दिया इसे भरने के बाद इसके प्रेशर से ये ऑफ भी कर सकते हैं एक्सपेरिमेंट.
You're adding more components into your system then. We want the paint to move itself. So this will always be at the same level, na? The barrel के अंदर paint. How will you ensure that barrel के अंदर paint खत्म हो जाए तो भी यहाँ से paint जाता रहे? Reflux हो जाएगा. This is gravity. Yes. So हमने अभी सब कुछ यहाँ पे ट्रिम कर दिया है. अब हमारे पास खाली पेंट है और बैरल है और टैंक है. And this is the solution that you just showed. What happens now? There is a void up there. And as soon as more air can flow into the, because if the level of the paint reduces, more air can now go into the tank, into the barrel. More air goes into the barrel, the paint will flow into the tank. As soon as this paint now reaches the level of the pipe there, now no more air can enter. There will be a built-up of void or vacuum. Vacuum nahi, but low pressure over there. And that low pressure will hold any further paint from draining into the tank. और ये आप हर रोज देखते हो. You've seen water dispenser जहां पे आप पानी की बॉटल को उल्टा करके लगाते हो. You just invert the water bottle and this is exactly how it controls the flow of water. You see this every day. And do you realize how elegant a solution this is? No motor, no lever, no float, nothing. Just the paint moving itself. So that is radical trimming for you. Now, do you want to apply it on your problems? We have.
The question is, how do we control this air pressure?
You don't need to control the air pressure; will control itself. The air pressure will control the amount of. Sorry.
For that, you also need another function, no? Just to control that void.
Do you have anything else in the dispenser that you put on the water tank?
So if it is like keep on flowing, then how will you control this?
कैसे फ्लो करेगा? जो ही यहाँ पे पेंट ऊपर चला जाएगा, अब एयर नहीं जा सकती ना ऊपर. Once the paint touches the head of this outlet, now more air can't enter in. And that is what stops. Because now the vacuum will start to build up or low pressure will start to build up. That low pressure will hold the paint. Oh, then how will you control? See, what you essentially need is that at beyond this level, no paint should flow. You want to increase one more pipe there, do that. But what we are saying is airflow up there can happen only if paint is below this level. That is the key condition. That airflow inside the tank will happen only if the paint level is low. Use two pipes, what's the problem? That doesn't change anything. One pipe can do the job, two pipes can do the job. That is your choice. We know air will not enter in if the paint has reached that height. Are you with me? As soon as you use two pipes, Tushar, the challenge could be that what if, suppose, both pipes are like this and coming from here to here? And what's the point? Why do you need at the bottom? Paint is anyway flowing from the top one also. Paint is anyways flowing from the top one also. Why do you want to increase the cost of your system? The flow would be turbulent. The flow would be turbulent, but it will still happen. कह रहा मोटा पाइप लगा लेंगे, टर्बुलेंस भी खत्म. ठीक है, now pick up your problems and try trimming on it. But you will try trimming only if you have the function model. So pick up one of the earlier function models that you have worked on. Could be the hair dryer, could be anything. But please practice, it is important. अभी practice करोगे तब आप अपने system पे लगा पाओगे. The hair dryer one you had done. All of you had made some function model in the last class. That was what we were working on. Please pick that function model up now.
Suggested about the storage system. So we can RAM system or some storage place. So my particular RAM is the RAM. RAM stores the stock of so what is this for right now? What is this?
Hold. Store is a hold. Store is hold. It holds SKUs. Hold is the function. Stores थोड़ा सा बहुत ज्यादा specific connotation आ जाएगा उसमें. तो holds is a simpler word.
So holds the stock of RAM. So this functions for the RAM is like rack frame or structure.
Function and components. So use the right word. Don't use the word elements. You say system components. If you use a different language, it will become tricky later for you.
Function components is rack frame or structure, you can say, and the shelves, the number of shelves, the rack height.
Height is a parameter. Height is not a component. Is height a component? No, it is a parameter. Space again is a parameter. Floor is the component. Super system component at that. It is not a system component. It's a super system component. These are targets. Because that is what you need to hold, to be held.
And this human operation, like
that is a super system component. Human is a super system component. They are performing some function. Access path is a super system component. That is some space on the floor.
Then one more doubt was like this thing, harmful and insufficient one. So the wastage of a vertical space is a harmful, right?
So rack is it's not harmful. Rack is able to insufficiently hold the SKUs. It is an insufficiently performed function. There is space in the rack, but it is not able to get filled.
So, insufficient hold of that is insufficient.
That is an insufficient function.
If you want, let's say the rack is now like 4.
That is not a function. Open door has no function. Where is the touch happening? What is the object of this function? How will you define it?
So, but increasing the rack height is also
Don't think about the solution. Think about the system, Adi. The rule is there has to be an object of the function. What is the object of this height? Very bad height is a parameter. You say the upper shelf of the. So what you could do is you could say upper shelf, middle shelf, lower shelf. So there are 3. Instead of rack, you talk about 3 shelves. Because once you say the rack, then it's one rack, and rack has a parameter of height. But you say, okay, bottom shelf taken care of, middle shelf taken care of, top shelf performs its function insufficiently.
So we can say we need to add more shelves.
I don't know. Don't jump to an answer.
Okay.
Go through the process.
Sir, this is when I have problem statement machine screen display is there. इसमें ये प्रॉब्लम मुझे बड़ी लग रही है इसका जो स्क्रीन कवर का
Either. I would say अकेले मत करो because we want you to work on projects. You have to form a team.
इस वाली प्रॉब्लम क्या है कि पूरी कार की बॉडी का एनालिसिस
नहीं नॉट यू सिंपली टॉक अबाउट द डोर. आप बोलो कि मैं खाली जो विंडशील्ड है उसको देख कर करना चाहता हूँ कि उधर से पेंट हट जाए, उधर से आइस हट जाए, स्नो हट जाए.
ऐसा है कि यहाँ पे मतलब उसका जो कॉमन जो मतलब अभी जो कॉमन सोल्यूशन है कि हॉट हॉट पैक ऐसे रब करते हैं थोड़ी सी आइस मैच हो जाता है, लेकिन जब कहीं बाहर होते हैं ऑफिस वगैरह में सब हमारे पास हॉट वाटर बैग कहाँ से है? अब उसके तरीके को काम किया था कि अंदर का जो मतलब एसी टाइप होता है अगर वो चल जाए तो कार को पूरी करेगा, टाइम लेगा. तीसरा तरीका पे तो किया था सिर्फ विंडो के पास जैसे हमारे एसी चैम्बर्स होते हैं, ऐसे अगर हम विंडो ग्लास के पास
होते हैं गाड़ी में होते हैं. अगर तुम गाड़ी का रियर रियर पेन देखोगे उसके ऊपर उसके अंदर एक सेट ऑफ वायर्स भी जाती हैं. वो वायर्स हीट करती हैं पीछे वाले ग्लास को, ताकि क्योंकि आगे तो वाइपर है, पीछे वाले ग्लास के ऊपर से हटाने के लिए वो आप बैक उसका भी हीटर ऑन कर देते हो. I would say work on the problem that you want to solve as your course project. This is the one. तो भी फिर टीम होनी चाहिए ना, तीन चार तीन लोग तो उनके साथ बैठो जाओ.
सर इसको हाइड कर देंगे, इसका भी सर इक्वल रहेगा तब तक इन दोनों का उसमें प्रेशर जो है सेम रहेगा. अगर सर लेट्स से इसमें से क्या है पेंट होना है और जो हमारा है पेंट पे जाना कार्य सर तो उसके बाद पेंट कम होगा तो सर इसका एटमॉस्फेयर प्रेशर कम होगा सर, तो यहाँ से पेंट से होगा.
एटमॉस्फेरिक प्रेशर हमेशा सेम रहेगा. एंड क्योंकि अगर ये ओपन में है तो यहाँ भी एयर आ रही है, यहाँ भी एयर आ रही है, एटमॉस्फेरिक प्रेशर सेम है, इनका लेवल हमेशा सेम रहेगा. तो नहीं कैसे सॉल्व हुई? अब इतना, अब इसका मतलब ये आपका डेड कैपेसिटी है, इतना सारा पेंट आपका वेस्ट जा रहा है. जो ये हाइट रही, दैट पेंट कांट गो इनटू दिस ना. हाउ विल दिस पेंट गो देयर? कैन इट हैपन दैट द बैरल इज एम्प्टी एंड द टैंक इज फुल? इट कैन नॉट, इट कैन नेवर हैपन. दिस इज द डेड कैपेसिटी, देन प्रॉब्लम इज नॉट सॉल्व्ड. टीम कहाँ है तुम्हारी?
सर इसमें ये हमारा सिस्टम फुल लाइन्स बनता है, क्या करते हैं छोड़ो ये हमारा सिस्टम है.
ठीक है. अरे नो, सो पहले चीज आपके लिए की डिसएडवांटेज थी दैट द अमाउंट ऑफ वाटर गेटिंग वेस्टेड वाज अ लॉट. What is causing that wastage? Is the storage tank causing that wastage? Where is the key disadvantage? How do you select the components to be trimmed? Key disadvantage is the one thing that you have to look for. ऐसे थोड़ा ना कुछ भी उठा के उड़ा दिया, पहले की डिसएडवांटेज ढूंढो.
disadvantage.
Where is this water wastage coming from?
Unless engineering system में ये components भी also
Water can be a super system component because it is not a part of your engineering system. The thing is that
बट सर अगर सर हम ट्रिमिंग करते हैं तो
सॉरी
मेन सिस्टम सर
नो, आपको खाली टारगेट नहीं एलिमिनेट करना ना, टारगेट तो आपका डस्ट है। सुपर सिस्टम कंपोनेंट को तो आप ट्रिम कर सकते हो, आप टारगेट को नहीं ट्रिम कर सकते। टारगेट इज डस्ट, टारगेट इज नॉट वाटर, वाटर इज अ सुपर सिस्टम कंपोनेंट। आपका सवाल ये था कि ये सिस्टम कंपोनेंट है सुपर सिस्टम, मैंने कहा इसको सुपर सिस्टम ही मानो। You can remove a super system component. And you don't use it and it's not there.
Sir, here again the same problem will solidify or not. Now paint solidify or pipe, the same problem.
नहीं तो उससे क्या होगा, अगर पेंट सॉलिडिफाई कर गया पाइप के अंदर ही तो पेंट का ही फ्लो ओवर कंस्ट्रिक्ट हो गया, रुक गया, पेंट आएगा ही नहीं, ओवरफ्लो तो नहीं करेगा।
आफ्टर सम टाइम हमें पाइप चेंज करना है,
बट ओवरफ्लो तो नहीं करेगा। I may need to at most redo some paint or some radiators.
The main problem floor.
मेरा जो शाफ्ट फ्लोर बंद करना पड़ रहा था मुझे 2 दिन, और पूरा वहां पे गाड़ियों की लाइन लगी हुई है, दैट वाज द मेन प्रॉब्लम ना, दैट इज हैंडल्ड। Team.
They're not there right now. They didn't come to class.
You have to ask them to come to class. अकेले. You have to ensure they come to class, otherwise you will struggle alone. टीम का है, बनाओ, यहाँ पे हैं कुछ लोग जो अकेले अकेले हैं। So how many of you do not have a proper team yet? You can raise your hand. यहाँ पे there are people who are also struggling alone. So please देखो कितने सारे लोग हैं, खड़े हो, सब लोग खड़े हो, जिनकी टीम नहीं है, जिनकी टीम नहीं है खड़े हो जाओ। Look around. If you already have a clear team, that's okay. If you do not have a clear team, just look around and form teams. Ideally 3 से ज्यादा मत करो, 4 करते ही someone will start to freeload. तुम तो हो 3 लोग। अच्छा, anyone else who doesn't have a team? Okay, this third one came to you ना? नहीं, ये कहाँ गया third one? So खड़े हो जाओ, बताओ यहाँ पे 2 लोग हैं, तुम भी 2। There are 2 people in that team, 2 people in this team. You are also 2 people. So stand up so that others come to you.
Sir, basically we have a team, but we're looking for a problem statement that is like good for the group.
Nothing else, use a hair dryer to practice now. तुम्हारे को क्या पता, तुम्हारे लिए तो ये प्रॉब्लम एलियन है, उसको उसके लिए सच है। करो सॉल्व है, हाँ करो। I'll come back on that. I'm asking you to avoid a group of 4. तो उसमें नहीं होगा ना, वो भी गया जहाँ पे, that team doesn't work on SRAM, तो corner 1, go meet them, that one. हो गया? Anyone else? You have 2 people, 2 तो हो कम से कम। You're also 2. Do some matchmaking यार। So I was just overhearing the discussion here. Trimming के बाद लगता है कि फिर ये काम कौन करेगा? जब मैंने कहा कि भाई Pump bhi hata do, let the paint move itself. It felt like a unsolvable problem. Don't sign it off just like that. Try to solve it. There could be a scientific principle that you could use. There could be some material solution that you could use. Don't give up just because आपको common parlance में उसका solution नहीं पता है. At least identify the problem. Now we will look at how to find solutions. That stage will also come, but at least identify the problem. So the goal of the trimming exercise is to identify other problems than the key problem, that the first problem that you had. Okay? Identify the problem. At least identify the problems. है ना? Solve कैसे करेंगे वो देखेंगे. आपके सिस्टम के जो कंस्ट्रेंट्स हैं उनको माइंड में रखोगे आप. सपोज आप कह रहे हो कि मेरे को वाटर वेस्टेज कम करना है. अगर वो सॉल्यूशन आप सपोज लगा रहे हो राजस्थान में, तो वाटर की कॉस्ट इतनी ज्यादा है कि उसकी जो आपने बचा लिया पानी, that could more than pay up for the cost of your extra components. You can look at it like that. How do I check it like this? Make the visual of it now. Make a visual, then I will see. ना ऐसे तो कैसे समझ में आएगा? Sorry?
Sir, we are thinking to form a group with Naman. He's already working on these problems and
So he has to commit to work on the project. But you can do it. उधर जाना है उसको. Let's go. क्या बोल रहा है ये? क्या बोल रहा है ये? आदित्य क्या बोल रहा है वो? ये बेचारा ऐसे ही फंस जाता है नहीं?
instead of the blade cutting the wheels, we take the robot there and stop all wheels.
Interesting idea.
हमारा जो कैमरा है,
So आपने बेसिक फंक्शन को ही रूल सी अप्लाई कर दिया कि बेसिक फंक्शन पे ही अब रूल सी लग रहा है. काटने वाला काम ब्लेड की जगह आपका व्हील कर रहा है. बट डू यू रियलाइज आपके व्हील को फिर शार्प एजेस वाला कुछ रखना पड़ेगा अपने पास. And when the wheel will now move on the soil, it will also start to get blunt. आपने सुपर सिस्टम में अभी सॉइल को नहीं प्लान करा है. Which is an abrasive material. That is a possibility. Yes. That is a possibility. That is a possibility. So then all that you need to do is have the shape of the wheel in such a way, design the wheel in such a way that it scoops. As it comes, it is carrying a scoop of it, and then you identify it. But then practically, if you look at it, then what we are doing is we are saying that the wheel has an arm. So instead of a separate robotic arm, now your wheel, where the body of the robot was holding the arm, now your wheel is holding the arm. That's what you've changed, practically.
Added a component.
I don't know. Your body could be now much lower height. It could be more stable. So there could be advantages to it. Don't give up. There could be advantages to it. I don't know. Your team also has Ujjwal in it. Hmm. You can think in this direction. Why not? Okay, so all of you have thought about it, played with your idea, and tried to apply trimming on it. Any questions now? Anything that you struggled with and you have found some answer and you want to validate? Maybe not yet, but please continue. You'll have to find time to sit together, either physically or in a Google Meet or whichever way. Please spend some time together as a team. It is extremely important. And uh, work on the problem after the class also. Otherwise, you will struggle big time. As I said, you're learning a new language altogether. Unless you use the language, you will not get the handle of it. So please do. Okay? All the best.